Okay, so we have 5 sides for a triangular prism, 2 triangles, 3 rectangles. So I'm going to call this one rectangle.
Can it go from any side?
Yes, yeah, because they're basically even. All right.
Mine didn't stick on.
Rectangle 1. Rectangle 2. They're even. Brian.
What?
Rectangle 3. And then triangle 1. Triangle 2. Are the triangles going to be equal though?
Yeah, maybe.
It should be. Yeah. Yeah.
Are the rectangles going to be equal?
Yeah.
It should be. I mean,
All right. So, some information that you guys need. We're going to kind of keep the same numbers. 10, 7, and let's do this one 5 right there. So this side is going to be 5
Then how come the top is silent?
because it's not going to be a square. And then the height of your triangle is going to be 8, the height. Because in order to find the area of the triangle, what 2 pieces of information do you need? You need a base and a height. Is this the height of the triangle? No, the height of the triangle is inside. Okay? So it got kind of sloppy right there, but it is what it is. Because if you just look at the triangle, the base is 5, but you need the height of a triangle. That makes a perfect 90 degrees, and the height of the triangle is 8. Okay? All right, so we have our surface area, our triangular prism as a net. What is the area of rectangle number 1? 70. We'll call it inches squared. What is the area of rectangle 2? 50. Okay. Before we do rectangle 3, what is the area of the triangle? 20. What is the area of this one? 20. Because it's 5 times 8 divided by 2. Now, we know on this rectangle 3 this is 10, right? What does this one measure? Well, let's check. 7 or 5, right? Well, I'm going to fold it up. If I fold it up, this is 7, so we're going to go with 7. The math technically is wrong. The measurements are wrong, but it's for the sake of our learning. So, rectangle 3 is 70. All right. So, just like yesterday, we got to find the area of each individual shape. Okay, so we're going to leave this side blank because we're going to glue this one on the left side. And on the right side, we're going to label it rectangle 1 equals 70. Rectangle 2 is equal to 50. Rectangle 3 is equal to 70. Triangle 1 is equal to 20. Triangle 2 is equal to 20. Surface area equals 130? 230? 230 inches squared. Are we okay? So, very, very, very similar to the one from yesterday. Got it? All right. So, later, in a minute, we'll glue this one down. Okay. Let's see if you can draw a triangular prism. Okay, start with a right triangle. This is a right triangle because it has a 90-degree angle.
It has to be a right triangle.
Now let's make it 3D. 3D. So I'm going to, this one back, and then I'm going to come down at the same angle as this one. Ish. I switched over to pencil for a reason. So you're kind of basically drawing a rectangle here. So, like this. You start off with a perfect 90-degree triangle, and then you kind of sketch out a rectangle there. Then from here, I go straight down, sort of, to make the back side of the 90-degree triangle. So that's the back side. And then if I dot this way, it becomes 90 degrees. And there I'm showing you my artistic abilities. Well, good thing is I would try to sketch, you know, don't try to do like a perfect line, just do sketch, and you'll see it. Not bad.
We'll see.
Of course not. I was able to do it, so therefore it wasn't hard. All right. So we're going to go with 3 centimeters, 4 centimeters, 5 centimeters, and we'll do 11 centimeters just to make our life a lot easier. So this is 3, 4 going up, 5 as a diagonal, and then 10, 11. You didn't let me finish. I was going to say 10 plus 1. All right. Done. So we have 3 rectangles, right? Rectangle 1, 2, and 3. Triangle 1, triangle 2. The triangles are the same size. Triangles are always the same size. The rectangles are the ones that change. Triangles are the ones that change. All right. So rectangle 1. It's hard to call it like the front side, the back side, the right, the top. It's kind of hard to see. But let's do the bottom one first. The bottom rectangle. It doesn't matter which one you call 1, 2, and 3. So the bottom one is this one right here. Okay, do you guys see what I highlighted? That's the bottom one. What are the measurements of the bottom rectangle? So I'm going to write that down. 3 times 11 is equal to 33 centimeters squared, which is why I chose 11 because the math would be pretty easy, right? Okay, so take a moment to realize, okay, where should I get the 3? Where should I get that 11? Okay, it's 3 by 11 right there. I did this rectangle down here. Okay? Now I'm going to switch over, and now I'm going to do the one that's on like the side over here, not the slanted one. I'm going to do this one. This back side. So what is this measurement of this line that I'm highlighting right now? No. No, this line right here. This one, this one. This one's 11 because it matches this one. Now, this line right here, 4. So for those of you who said 55, not okay. So this back one, I mean, you're not terribly wrong, but you weren't using the one I wanted. So this one is 4 by 11, which is 44 centimeters squared. Now I'm going to do the one that's like the slanted one. which is this part over here, this whole thing. It's kind of sloppy, but if you're following along, if you walk in right now to the class, you would be like, what did they just do? If you've been following along, you realize, okay, first she highlighted this bottom one, then she highlighted the back one, now she's highlighting the front one. But if you walk in, yeah, it looks really confusing. Okay, so what are the measurements of this orange one? 5 times 11, which is equal to 55 centimeters squared. Another way to check if you're doing them right is, did you mix all the numbers up? You know, is it 11 times all the other numbers? Okay, triangle. What's my base? 3 times 4 divided by 2 equals 6. So this one's 6. All right, what is my surface area?
Four
44? It's not that I don't trust you, but let's use a calculator. Hey, Miss Celine. How many of you know Miss Celine?
Oh, me.
Yay! So Miss Celine will be joining us on the second part of the class. What days?
Tuesdays and Thursdays.
Tuesdays and Thursdays. Okay. Yeah, for the rest of the year. I know.
44.
So there's no excuse for failing now. You have extra help.
Oh my God, this is such a small.
It's huge, I'm telling you. And they're all like troublemakers, and it's like headache every single day. Oh. Let's just keep that between us, though. No one needs to know. All right. 33 plus 44 plus 55 plus 12. Wow, that sucks. 33 plus 44 plus 55 plus 12. Yay, you guys got it right. 144 centimeters squared. Are we okay? Okay, you're going to need your notebooks to keep track of your numbers. We're going to worksheet just like yesterday. You may use a calculator just like yesterday. I'll pass out the glue. Just like yes. Yep.
Is it dumb that I was about to put it out?
Yeah, so I guess.
It's snowing. Oh my God.
Hurry up, Brian. Yeah. All right. So, first thing, I'm going to glue rectangle 2. Just going to glue rectangle 2 to my notebook. And then if I need to build it, I have it there, right? And then it lays flat to store in my notebook. Rectangle 2. I don't know if, I'm wondering if I would glue it the other way it's better.
Yeah,
Like,
the only one that's different.
true. No, I was thinking like, what if we glue it this way? All your numbers are hidden, but at least you see the triangular prism and then you see the map. It's up to you. You guys know your notes. Yes, you may use a calculator. All right. Ladies and gentlemen, you have to show me the numbers in your notebook. You have to. This is way too complicated to keep track in your head. You may use calculator, but like I just said, you gotta show me what you're doing. So for number 1, tell me what is rectangle 1's area, rectangle 2's area, rectangle 3, triangle 1, and triangle 2. I'll give you a clue. The triangles are the same. Triangles are the same.
All on the
Yeah, the rectangle.
On all of them, yes. I want to make that, yes. All the triangles will be the same. It's the rectangles that are all different. Maybe 2 are the same. Unless you have an equilateral triangle, then all the rectangles are different. What's an equilateral triangle?
One that's equal on all sides.
Yes, one that's equal on all sides. Alright. Jared, there's trash in between you two. Whose is it? There's 2 scissors on the floor. I wonder whose is it. Okay, what's the first rectangle? What are the measurements of the first rectangle? Thank you. Thank you. Miss Lillian, here's the answer to the first one. That way it was flew on. Who's on the right track and who's on.
Whoa.
Doesn't matter. Just as long as you keep track of it. Doesn't matter which one's rectangle 1, 2, and 3, just as long as you keep track of it. You keep track of which one you want to call 1, 2, and 3.